Tonight, I want to talk about citizen science and the role that it might play in addressing some of our environmental challenges. But first of all, I want you to just indulge my passion for Alice in Wonderland by giving you a little metaphor. How many of you know the Alice in Wonderland story? Everybody? Yes. Well, so the story, the bit that I'm picking out is that Alice is sitting with a wet and rather bedraggled group of animals who've fallen into the lake of her tears. And the mouse, there's a mouse in the story, he recites the history of William the Conqueror, which is apparently the driest thing that he can manage. And he gets shouted down by all the others, and then the dodo suggests that the meeting adjourns for the immediate adoption of what he calls more energetic remedies. And then there's a protest from the eaglet and everybody else that the dodo's language is incomprehensible. And without any explanation, and the dodo just says, well, the best way to explain it is to do it, he marks out a kind of circular track and he starts a caucus race in which everybody participates. They begin running when they like, they let off when they like, and so it's not easy to know when the race is over. However, after they've all run for about half an hour and they're all dry, the dodo suddenly calls out, the race is over, and they all say, but who's won? And eventually the dodo announces that everybody has won, and they all must have some prizes. Now, I don't want this to sound like some form of Sunday sermon, but let's just pick up the salient points here. What we have is an environmental catastrophe, a flood, affecting everyone. They don't understand the background to the disaster, although several of the characters realise that Alice is broadly responsible for it by crying, even though she didn't understand the implications of what she was doing at the time. One aspirant leader, the mouse, is shouted down because his suggested solution is boring and ineffective. And another character then suggests, albeit in almost incomprehensible language, that by doing something broadly competitive, they will all benefit in the long term. Now, they mark out a course for the event, but there are no rules, no targets, and no agreement on when this proposed activity, which is running around the lake, will be finished. But they do all join in, and when the damage has been repaired, they are told that they've all won and that they're all going to have some sort of prizes. Now, I don't want to push this metaphor too far here, but I think you can start to see where I'm going with this. This is a pretty good allegory, actually, or do I mean allegory or analogy, for the ways in which we're addressing some of our environmental challenges today. Boring, incomprehensible language about possible answers to challenges, rather shambolic arrangements for activities in which the citizens, in this case of Wonderland, are supposed to join in, a bit of competition, but a lack of agreement about whether we've reached the solutions, and not being experts, if you like the dodo, the citizens don't really understand what they're doing, but it works, more or less. They all benefit, and even without full collaboration, perhaps they enjoy it, but we're not told that. Now, I want to park that for a minute and switch over to talking about science and citizen science. We've recently seen an upsurge in the prominence of scientists in the media. In some cases, this is because of a lack of confidence in the abilities of scientists, and we're probably all familiar with phrases that have been bandied around in the media about there being too many experts and so on. But scientists themselves have also been seeking greater prominence, and the slides here tell their own story. Last month, for example, scientists marched in cities across the world, including London, to promote science. And the messages they sought to convey were about the crucial role of science in decision-making, the importance of innovation, and the need to establish some form of reality. Alongside the medics and the physicists, and I think we've got some pictures here, alongside the medics and the physicists who were saying things like science save lives, and up and atom, I think, which is rather good. Environmental scientists were also pretty well represented. The climate science was particularly prominent. So climate change is not a Chinese hoax, one of the placards says. And the placards themselves, actually, were models of good scientific procedures. This one I like. What do we want? Evidence-based science. When do we want it? After peer review, which is pretty good. And I think there's a bit of a sense of humour there. There were also placards disputing who scientists were or who they could be. So science is for everyone, but there's that little hesitation, isn't there, although it needs decolonising, which is a kind of interesting. And this one I particularly like. My mummy is a scientist. Scientists are badass. It's good. And then this one, that's who scientists are. Okay, now, for environmental scientists, perhaps it's this placard that best captures the balance of opinion in the play on words. If you're not part of the solution, you're part of the precipitate. So for the chemists amongst you, we'll get that. The point that these placards are making, at least in part, is that everyone can be a scientist and a citizen, if sufficiently nerdy, perhaps. And citizen science, therefore, needs to be part of the solution. Now, let's just tease this out a little bit. Citizen science is people power, basically, where volunteer non-scientists are used to report on phenomena such as the date of grape harvests or cherry blossom flowering dates. To that extent, citizen science has long been science has long been the province of the amateur or the citizen. 18th century clerics with time on their hands and Edwardian ladies looking for a pursuit beyond the taking of tea have recorded phenomena such as daily rainfall totals, the presence of particular species such as orchids or butterflies, for example, for centuries. The earliest geologists are people such as Mary Anning, who dug out and sold Jurassic Coast fossils and made some interpretation of them, was a complete amateur, of course, in most people's understanding. I'll come back to her later. Even when I was undertaking my own doctoral research on river channel erosion a very long time ago in the 1970s, I found a man in Preston who had recorded the river level of a particular bridge every day for more than 50 years from the top deck of a bus whilst on his way to work in a factory. And even without the weekend observations, because he only worked Monday to Friday, it was data worth having for me. And of course, I thought to myself, was this man a scientist monkey? Now, this definition of citizen science is very simple, people power. But there are other definitions of citizen science, some of which suggest that the role could be much more significant in driving people to be part of the solution. The quote on here, for example, from Irwin, suggests that citizen science is a precursor to opening up science policy and science debate to the general public. When people are well informed through personal engagement, they're better able to participate in democratic processes. The suggestion, therefore, is that citizen science isn't just a neutral term concerning specific activities such as data collection, the date of the grape harvest or whatever, but an altogether deeper and broader concept. It raises the possibility of the science responding more explicitly to public concerns. This is a graph of cherry blossom dates in Washington, D.C. On the Mall. I think some of you may even have seen those, the trees there. And it actually illustrates quite powerfully, I think, the policy connection that comes from citizen science. Blossoming dates, if you look carefully here, have been getting notably earlier since the 1960s, as observed and recorded by every man. And one would think that this would prompt thoughts about climate change, as well as the increasingly unreliable method of setting the start and end dates of the National Cherry Blossom Festival, which keeps coming too late. It's a slightly odd diagram in that earlier dates are at the top of the diagram. So towards the right-hand side, the trend is apparently upwards. So the point here is that citizen science isn't a new phenomenon. It's evolved very quickly over the last 30 years or so, and in the environmental sciences particularly over the last decade. The first noteworthy citizen science of the 21st century is probably the Dutch volunteer Van Arkel, who was analysing actually thousands of images emanating from the Hubble telescope. And from that, he identified a new type of celestial body, something called a quasar-ionization echo, or a bright streak, which you can just about see on the right-hand side of the diagram there. In addition to that, of course, there are still citizen science programs hunting for aliens and UFOs and so on. However, a decade later, we've got scientists at the University of Oxford asking for Higgs hunter volunteers to search for the Higgs boson. The picture is a joke, of course, but technically it's a baby Higgs boson with a slightly longer lifespan, and they examine images from the Large Hadron Collider to see if they contain anything weird or unexpected, because the human eye-brain combination is very good at detecting weirdness. And then the people flag up their observations to the scientists running the project, which is what our Dutch friend did in the previous project I mentioned. And in some cases, the set of observations is used to fine-tune the algorithms that will subsequently be used for machine recognition. So, as everywhere else, I suppose we humans will going to be out of a job soon, but there have already been 20,000 people involved in this project. They've got 60,000 images to analyse, and they've only done 20,000 so far, so I'm kind of assuming that's rather a painstaking task. However, on the environmental side, we environmental scientists have been a bit slower on the uptake than the physicists. There are examples of citizen science from the 1970s, but relatively few. This one, in 1987, the Audubon Society in the States drew on the labour of about 200 volunteers across the country to collect, analyse and submit data on the acidity of local rainfall. So the analytical method used litmus paper. It's not very accurate, and in fact the collection method used old cola bottles, so if there was any residue in them, the accuracy of that pH measurement must have been very problematic indeed. But the information was deemed good enough to demonstrate that acid rainfall was associated with industrial activity and was widespread. And the Audubon Society went on to use that as a lobbying point with government. Now, greater emphasis today is being placed on scientifically sound practice, and there are often goals for public education as well, which is something I'll return to later. The other thing that's been responsible for the meteoric rise in the practice of citizen science in environmental realms is the massive improvement in the accessibility of technology. So things like global positioning systems, satellite images, mobile phones, drones and so on have become cheap enough to be deployed by almost anyone. And what that has opened up is huge and interesting possibilities. I'll show you an example here where in the States, potentially amateur scientists are being used to survey songbirds. So they're looking at songbird populations, and they're doing it in this particular case by dangling small digital recorders 60 metres over woodland from drones. And I've got a little video extract which I will show you. Okay, and now he's off. And they do the analysis, scientists do the analysis back at base. So what they're checking here is whether what the conventional recording using binoculars records and listening is comparable with what they see from the drones. By and large it is, but the problem is that the mourning dove, which is one of the species that's really important because it's protected, can't be heard over the buzz of the drone, so it's problematic. But as you can see from that, this kind of technology, in this case drones, is opening up science to people who like playing with fun devices like drones and previously have been where the science has been reliant on either very high levels of skill or very specialist technologies. In this case, the study was done by Gettysburg College in Pennsylvania. It's not a research-intensive institution. So, that's an example of citizens collecting environmental data with some more or less specialist kit. If we return to the question of definition, though, the European Commission produced a paper in 2013 which developed that proposition about data collection much further. And I'm sorry this reference is, this quote is rather long, and I won't read it all out, but there are a number of key elements that I want to pull out of this, particularly to start off with the words in purple. They refer to raising new questions, citizens raising new questions, and co-creating a new scientific culture. So that's about collaboration, proper collaboration between scientists and citizens, not just citizens measuring something, but developing the project together, framing and steering research. And there's an educational ambition in there, and there's an expectation that it's going to be interesting. And then it talks about, in the words in red at the bottom, about this link with the development of policy, which could be conservation policy or environmental protection policy of some sort. Now, those ambitions for engagement are, as you see, well beyond the provision of scientific data to scientists. Increasingly, too, in the academic world, there are demands from the funders of research to get impact for the money that they invest. And that also is very important. We can see, for example, a new online journal has appeared recently called Research for All, co-sponsored by University College London and another organisation, which anyone can read freely, including citizen scientists. And it's about, in that case, exchanging research ideas with citizens, including, allegedly, citizen scientists. Now, having said a little bit about the background to citizen science in environmental and other disciplines, I want just to turn my attention now to the realms of environmental science and just look at a few examples of what has actually been done and is being done. And if you feel so moved, in the projects that I'm going to talk about, you could be involved in any of them yourselves. So for convenience, I'm going to split them into the broadly environmental but rather classical elements of earth, fire, water, and air. So first of all, let's have a look at the earth ones, and I'm going to include ecology in that. Now, very straightforward one is something called the Lost Ladybug, ladybirds in UK parlance, citizen science project based in Cornell University in New York State in the US. Actually, you could only do this one if you went to the States, but it started in the year 2000 as a survey of ladybird populations. And then in 2006, two 10-year-olds found the extremely rare 9-spotted ladybird. And so the National Science Foundation pitched in with some money, and now groups of citizens, particularly school children, have collected, chilled, counted and photographed 34,000 ladybirds. What they do is they kind of go round brushing them into glass bottles, and they stand the bottle on some ice, and then the ladybirds not unexpectedly calm down because they get their feet cold, I suppose, and then they're photographed through the glass, and then they're released again. Now, the photographs are then sent to Cornell for analysis, but the participants get some kind of taste of the thrill of zoology. And the project mission, sorry, I moved on a bit too quickly there. The project mission is to help children become confident and competent participants in science. So they develop a generation of adults who are engaged in science discussions, policy, and so on. And the data itself is also of interest because the 9 spotted ladybird has been in decline since people messed around by introducing alien ladybirds, apparently in the interests of agriculture. That didn't work, and they now eat the 9 spotted ladybirds, which is not good, obviously. The creator of this project has argued that the cost effectiveness of this kind of data can outweigh data quality issues if it's properly managed. And that is a key point, and one I'll come back to later. But in this case, stuffing some ladybirds in a glass jar and photographing them, there isn't much possibility of actually error in the methodology with that. There's a bit more possibility in this one. Some citizen science projects also record larger animals, either in the field, this one's in Glacier National Park in Canada, where they're recording goats, bighorn sheep, and raptors, birds of prey. And it's amateurs doing this, directed by park staff. I can't resist showing you this one, which wasn't taken on the site, but the recording of grizzly bears is apparently best left to specialists. So despite the rigour, not to say the hostility of these high altitude environments, the project is less interactive than some of the others, and the data isn't really displayed for general education. But what the projects say is that for citizen science, the rewards are a sense of stewardship, a greater awareness of the park's resource issues. That means that people understand the park hasn't got any money, I think, and an expanded insight into ecological research methods. And for the park, they get the data, of course. So those are important issues of emphasis, and I'll return to those later. If we go to the southern hemisphere, and a different form of observation, Weddell sea seals are being counted by citizen scientists. Now, it says on the site, from the comfort of your couch. It's one of a set of live projects that use the web to broker interactions between citizens, species, and scientists. So in this case, the volunteers are counting seals that appear in 300,000 satellite images in key areas of the Southern Ocean where human overfishing of a particular fish, the Antarctic toothfish, is suspected. Apparently that fish is a delicacy in Chile. It actually, from the name, sounds rather unpleasant, but apparently the seals are also rather partial to it, and they are declining. So what happens is the website offers up images which can be zoomed in on. So if you log in, it offers up some images, and you move the cursor around, and you click where you see a seal, okay, spotted from a great height. You can zoom in. And apparently, the records generated so far, the project says, are estimated to have replaced 11 years' work by trained scientists. I have actually played around with this. I did wonder whether it was possible to sabotage it with multiple clicks on nothing, but I didn't actually do that, you'll be pleased to know. You can do a similar thing with penguins and their chicks and eggs, again, depending on your species preference. This is working with Oxford University, and they have static video cameras monitoring populations of penguins, and because penguins are the top predator in this area, it makes them a good indicator of overall ecosystem health. There's been no shortage of volunteers to do this work. This is what you do. It's the same sort of thing. You get a picture and you put blobs on penguins, chicks and eggs, and then it goes back on and you get the next image and the next one and so on. No shortage of volunteers to do this work, and that applies to other projects as well. There's one here, Snapshot Serengeti, which uses hidden cameras based in Tanzania, and in this case the volunteers are prompted to choose a potential type of animal that they see on millions of images. So this one, it says something like, it looks like a giraffe. So you click that if you think that's a giraffe. The classification, as you see on this, is pretty basic. Okay? If your tastes are more for the cold-blooded, and you've got an hour to spare, you could look for earthworms in your garden, and there's plenty of assistance required by the Natural History Museum here in the UK in evaluating soil health in the UK from earthworm observations. And there are a number of angling organisations, and if you're a member of those, you have to be a member in this case, you can undertake sampling of stream beds to identify flies as indicators of river health. Now, the Flies project actually involves volunteer training, so you have to be trained as part of a group to do that. But a more complex operation is in this one, which is the Bat Detective project. In this case, the scientists coordinate the collection of sound recordings. They go out and do the recordings, and thousands of citizen scientists use the spectrograms and some software to separate out the bat calls from other noise, and then they classify the species and submit their findings. So what's actually happening there is that people are using their judgment and the shapes of those curves to identify particular bat species. And you can see there's a map of Madeira where that's been done, and there's lots of other areas around the world. And you will probably know that in the UK, some bat species are threatened with extinction. So it's an interesting project. Now, if we pause for a minute just to think about these citizen science projects, and specifically the extent of volunteer engagement, there are clearly different levels of engagement. And there's a chart here from Hackley and indeed lots of others that have suggested a spectrum of possible participatory levels, from level 1, which is they call here crowdsourcing, where people just collect data, or as we'll see in a minute, they allow their home computer to be used by scientists for processing large data sets. I'll show you an example of that in a minute. But the Lost Ladybug project that I talked about earlier would be an example of that. People just collect the bugs, photograph them, send them in, that's it. So they get the fun of the chase, but they don't do any of the analysis. Now, if you go up the chart here through levels 2 and 3, of course, you get progressively higher levels of autonomy and judgment expected from the participants. So, for example, the seals and the bat project. And when you get to level 4 on this, you've got a truly collaborative science where projects themselves are co-produced between teams of specialists working with citizens. But in fact, there are relatively few examples of that. The nearest I've been to this myself was a project that I was involved in looking at communications between scientists and local authorities on flooding in the River Severn. And the project was called Project Foster. Those of you who know anything about UK nursery rhymes will know the rhyme. For the benefit of overseas viewers on the web later, I'll just say it. Dr. Foster went to Gloucester. You could join me, couldn't you? Dr. Foster went to Gloucester in a shower of rain. He stepped in a puddle right up to his middle and never went there again. The project was called Foster. It was an anagram. Do I mean an anagram? A series of initials. It was flood something, something, something engagement and research. There was science and technology was in there somewhere. So that was involved local authority people setting the parameters of the project, indicating what they wanted to know about flooding in order to be able to manage it, and then together we explored the optimum ways of developing understanding of those issues and challenges. So that was moving towards level 4, but it's actually pretty difficult to do. Now, interestingly, quite a few citizen science programs are actually, when you look at it, they're a series of lectures, not dissimilar to the Gresham series here, where they don't really involve the active participation of the audience. Now, lectures, of course, have a different purpose, and they're not, in my view, really citizen science. They might provoke you to go and do something later. But other groups around the country would say, particularly if they're receiving grant funding, that they are doing citizen science, but actually they're giving a few lectures, which isn't, to my mind, really appropriate. Now, let's just move on. The next of our elements was fire, and specifically temperature-related citizen science project. There are fewer of these, I think, than the ecologically related projects, but they do illustrate some different characteristics. Some involve citizen volunteers spotting natural fires on satellite images in rather the same way as they spot seals, and reporting them to the authorities. We might also have things like postings of comparative photographs from volunteers of such things as the snouts of glaciers, as in this image here. They're using the volunteers' energies to access rather inaccessible locations. It's easier to get your volunteer to trek up to the top of the mountain than to drag yourself up, perhaps. The largest example of citizen science in this realm is, again, and I'm sorry, this is rather Oxford University focused, and I do have a connection myself, so I'm sorry about that, if there's anybody here with other university connections. But Oxford University has a project called Climate Prediction Net. It's directed by Professor Miles Allen, and what they do with this one is that the home computing power of thousands of volunteers is being crowdsourced to run computer models that simulate the climate. And they produce millions of predictions of temperature, rainfall, and the probability of extreme weather events in the face of increasing levels of greenhouse gases. So what happens is the software is downloaded to your computer, and your computer churns away with some data sets, and typically over a period of days, or perhaps up to a month, the data trickles back to the university and is assembled into hundreds of thousands of runs of this model. These make up something called ensemble climate models. It's an important area of research. So it relies on running the same model with slightly different starting positions, hundreds or thousands or even millions of times. And it's better done, or in fact, in some cases, the problem is too large. Is it? Is it the bat's back? No, don't know. Anyway, you run thousands or even millions of these runs to build up these models. The output is each one is slightly different to the others, but it plausibly represents the real world in the next 100 years or so. And it's too large for a supercomputer to do even. So each individual computer, it could be yours, tackles a bit of the research and feeds the information back. Now, the interesting thing with this one is that the volunteers are not involved directly in the synthesis of the data at all. Although there is an educational part of the website which explains what happens, but the number of participants is very, very large. It's thousands and thousands of people. And then one interesting dimension of this as well is if you want to know more about it, you can pay for a course at the university. So there is a commercial element in that one. Now, that work on climate change clearly has a political context, but the other climate element I want to show you is a project taking place in an extremely charged environment politically. Many of you will know that South Sudan is suffering from conflict, food shortages, and drought. And using satellite imagery, volunteers are being asked to tag permanent dwellings, circular-shaped huts, and tents, which suggest that people are on the move with their animals. So they're being asked to look at a satellite image and make a judgment. Is this a permanent settlement, a house, or a tent that suggests that somebody is on the move, perhaps as a result of being driven by drought? The project, and they move their herds of livestock as well. The data set is then used to assess the level of food insecurity in South Sudan. Now, clearly this is a very worthy endeavour, but given the sensitivity of the data, I think there must be issues about the accuracy precision and representativeness and so on of the conclusions, because lives will depend on it. Lives will depend on the policies that emerge from the exercising of the judgments of volunteers as to whether what they see is a permanent or a temporary dwelling. Now that's quite a serious matter, I think. And I think it flags up, in this particular case, some other issues about the costs and benefits of citizen science in the longer term. Big questions, not only about the accuracy and precision of data, but whether volunteers should steer such a programme, or whether the programme might actually be diverting resources away from, in this case, aid on the ground. So those issues raise their heads. Now, turning to the third one of the areas of interest, water, I'm going to go through very quickly a series of projects here. The theme of water pollution monitoring by citizens is very common, but less usual is a citizen science project in London here, which determines the status of urban rivers, and specifically their form and the general habitat status rather than the detail of the chemistry of the water. This one's run out of Queen Mary College, and in fact the project evolved. They produced some guidance notes for participants. The project evolved, and now it's the basis of one of the Environment Agency's areas of work on river habitats. What they do there is they train citizen groups to use logging sheets to look, for instance, at the background to areas where river restoration to more natural situations is being proposed. At a larger scale, we've got things like Freshwater Watch, which is testing, again, citizens testing rivers and ponds for nitrate and phosphate content. Contaminants there arising largely, but not wholly, from intensive agriculture in the UK and elsewhere. You'll notice there's a map here showing where they've got these observations. There is a strong bias towards Europe, but there is some African coverage, for instance. And they do have a specific programme in the Thames area, actually, from which the complex pattern of results may be seen there. Okay, again, the point about this is that the interpretation of these findings, they sample the water. See, they've got the gloves on there. They're checking with some indicator solutions various chemical characteristics, nitrate and phosphates. And the results here, which you see for the Thames, clearly are going to be quite complex to interpret, and that is not done by the citizen scientists. There is some potential for error in the methodology. And the other thing that arises with this one is that there is quite a strong bias, because people like sampling ponds, and it's much more dangerous to sample rivers. So there's quite a strong bias towards sampling static bodies of water. Now, that wouldn't matter particularly, except that if you go on to start making policy about water quality on the basis of those analyses, you're likely to find that your samples are not representative of the wider areas of the ground. They're very particular. But I guess the volunteers enjoy the walking and the working in a team, and I think that's good fun. This is another example where I'm sure the volunteers enjoy it. This is making use of specialist skills of volunteer divers and collecting marine litter and analysing marine litter. And at this point, I just want to recommend this. I've got the Chief Executive of the Institution of Environmental Sciences in the audience, so I have to do this. But this is the Environmental Scientist Journal, and you can download it for free from the internet, and very good it is too. This is a whole issue on citizen science, but you'll find many other issues. Somebody was asking me earlier about air pollution, and the latest edition, not available to the general public for 2 or 3 months, but the latest issue is on air pollution. But do look, you'll find it easily, I'm sure. Okay, so marine litter, that one, that's if you've got the kit. Finally, I want to just show you this one with a slight note of caution on water. This is again a project in Oxford. It's a fully commercial project to collect data from citizens using the Internet of Things. And what they're doing is they connect together cheap sensors which are installed by volunteers on their own property, and these sensors communicate with each other using spare bandwidth out of the TV range of the electromagnetic spectrum. So it's a kind of techie thing. It's part of a smart city programme, and it's suggested that this will fill in the gaps between the monitoring done by the Environment Agency. Now, what I like is this quote here from the setter up of this company. It's called Love Hertz, and he says, "I wanted to create a guerrilla sensor network collecting citizen science data but without necessarily getting permission first." Some of you may have come across the urban explorers. Have you heard about those people who start climbing up the outsides of buildings without permission or going down tunnels and so on? There are some resonances here, I think. What's going on here is that he's getting people to take photographs, he's integrating it with other people's data, and in some cases, he's going to sell that information. This is a mock-up of only the first run of the data, and it's not clear who the market for this might be, who the customer might be. But anyway, a commercial operation. Now, one or two very quickly more. Here's one in the Peak District, Moors for the Future. This one has citizen science mapping habitats, groundwater, bees, butterflies, sphagnum moss, and all sorts of other things on the ground, and they have guidance sheets and so on. They produce maps like this, which is about bumblebees and bumblebees over time. You can see and different kinds of bees and so on. Collecting data. I'm going to skip that next one. Let's just turn finally to the air, citizen science and air quality, which is, again, some people here will be aware, as I said earlier, I lectured on air quality a few months ago, and since then, but not as a result, I don't think, the subject has gone massively up the political agenda in the UK and internationally as well. Now, I don't propose to talk about that shift now, but I would just want to talk about one citizen science project that's being promoted, asking for people to invest in it, what they call Kickstarter investment. It involves you buying a tiny sensor called Spremo, which sits in the bottom of your mobile phone. You can just see it, that's it there. And you plug it into your iPhone, and it will give you, as it shows on the screen there, it will monitor the air, apparently, and give you personal data about your exposure to pollutants. And then it will collate the data together and make maps based on many participants, if lots of people have bought one of these things. Now, maybe there is some potential for that being useful because air quality varies over very short distances. But assume most of you know that it's generated principally from diesel vehicles, and it peaks around major roads. But the problem with the sensor, and it is a big problem, it is, first of all, it's going to be extremely inaccurate as a spot measurement, and also it measures only some of the gaseous elements, not those tiny particles that cause most of the damaging health impacts. So this one, you can look it up on the web if you like. It's seeking investment, and I'm not an investment advisor, obviously, but, and I'll just pause there for fear of being sued. Now, let's quickly review what we can learn about citizen science from these examples. Firstly, why do scientists wish to engage volunteers in research? And that's a question which is almost loaded because it assumes that the research ideas are coming from the scientists. Citizen schemes might be cheap, they might be well distributed across the world, they might be able to sample and capture multiple points of sampling in space and in time as well, and they might be willing to take on physically challenging activities. And some scientists might have genuine educational outreach commitments, and some are being driven by their research leaders to engage with the public in some way to improve their university's position with government or whatever. There has been a report recently on this, and it produced a template for scientists to evaluate whether or not their research might benefit economically or in other transparent ways from public participation. But there could be other potentially more sinister and hidden motives, of course. Power and influence, financial gain from selling stuff to the volunteers, and occasionally, of course, the theft of volunteers' ideas. And I've got Mary Anning down there because I think she was probably a victim of this. She was never 19th century geologist in Lyme Regis, for those of you who don't know. She, as a woman, she was never allowed to present papers at the Geological Society, and she was living in poverty almost throughout her life, whilst the benefit of her labours accrued largely to Anglican clergy scientists. And she wrote a very interesting quote in a letter. She said, "The world has used me so unkindly, I fear it has made me suspicious of everyone." And who could blame her, I think, for that? So that's why environmental scientists might want to call on citizens. But why do citizens want to join a research team? Well, again, there's a mixture of self-directed motives, things about themselves, their passions and so on, and altruistic motives, suggesting they might want to support a cause or feeling it's important to improve their local environment. The ones on the left, of course, include the science acting as a sort of dating agency, where you can meet other people that share your passion for, what was it, earthworms, perhaps? Or seals, or whatever it might be. Okay, so the point that I want to make about this is that the motives of the scientists will only be met at particular levels of this hierarchy. So if they're actually seeking to develop their proper understanding of science, they'll probably only be able to do that from projects that are at levels at least above level 1, or even my level, level 0 that I had earlier. Otherwise, even the bat call analysts and the urban river classifiers, they don't participate in setting the research agenda. And those people who lend their computers to the University of Oxford for processing climate data might not get a deeper understanding of any scientific principles at all, other than how to connect up your computer, perhaps. I'm going to skip over this one. Research has been done on this which tries to capture the benefits to individuals of different kinds of projects, but there's going to be a print of this lecture which is available afterwards, and you can have a look at my text on that. The point about this is that in evaluating the potential costs and benefits of citizen science projects to the scientists or the citizens or society in general, there are some fundamental principles of science which we need to bear in mind. The goals of scientific inquiry are to be objective and universal. And in the cases of citizen science, it's clear that objectivity is quite difficult to achieve. People, for example, might be tempted to record a Weddell Sea seal when there really isn't one present. The citizen science really wants there to be one there, but actually there isn't. Our monitoring of the mass human migration following drought and war in Sudan is another example where it'd be quite hard to ensure objectivity. Participants may have particular axes to grind, either unconsciously or consciously, in what they record, or the accuracy with which they record it. They might, for example, hope to show that people are moving and that a disaster is impending, or possibly they don't. We just don't know. The people wanting to win the points to become top citizen scientist in Freshwater Watch might also have other motives for recording things which mitigate against objectivity. And universality might also be a problem. Some sites are going to attract a lot of interest, and some species, the cute animals, for example, are going to attract more interest than others. Some places are more accessible than others. The Thames Basin is probably more accessible than the Highlands of Scotland or Central Africa. So even though we would have widely distributed search teams in some of these projects, people are keener to be involved in some projects than others. They're keen to be involved on research on ladybirds and goats, and even actually the travel distances of garden snails that devastate their vegetable plots, which was going on last year. And interesting project at the moment on the murmuration patterns of birds. That's those huge swirling vortices of starlings. But they're not so interested in rats and bacteria, one suspects, even though those are key elements of ecosystems. Now, at the worst, some scientists have said that citizen science actually damages science research. Scientists, for example, some scientists have said it redirects funding away from core science and it disadvantages trained scientists who can use this sophisticated equipment personally. They can ensure the quality of their data and they can communicate effectively, perhaps. At another level, there's a quote here from some German scientists suggesting, or German economists actually, suggesting that improved citizen science monitoring can have immediately bad effects on environmental quality. What happens is that people start reporting massive numbers of breaches of pollution levels in rivers, and the costs to the regulator and the industry in dealing with these thousands of reports of minor breaches overwhelms the environmental benefit that could be gained from a more synoptic or a broader approach to this. Now, I have to say, and what happens is that the regulators just become less efficient at delivering improvements in overall quality. Now, I have to say that, sorry, I've got these in the wrong order, forgive me. That was one of the things that was in this paper. This is not a paper designed for public engagement or citizen science, I'm afraid. So, what can we say then? That's a quote, again, from their research. It's completely impenetrable, and you can perhaps look at it later, I think. Okay, so can citizen science deliver? Well, possibly. If you summarise things very simply, the potential benefits of citizen science are many, actually, and every project needs careful evaluation, even if, on balance, the involvement of citizens appears to be an immediate advantage in terms of saving money. However, if you consider the broader aspects and not the larger data sets, potentially the lack of quality or bias or inexperience or maybe even damage their subjects. One or two of the early citizen science ladybird projects involve skewering the ladybirds on pins and then counting them, which is obviously not good for the system at all. This quote, though, I think is worth looking at. The quote is talking about, if citizens are going to live with the benefits or potential consequences of science, and most of us will, then it's incredibly important that we are not only well informed about the changes in science, but that we can influence science policy decisions. And that's where the citizen science offers people an opportunity to involve people effectively with environmental policy decisions and avoid some of the worst excesses of policy that's not informed by the evidence. One of the posters in the march in April suggested it's time to react. This is about getting people actually involved in doing something with the science. And even bearing in mind the mental and physical sweat, involvement in citizen science actually not only is giving you an entree to policy discussion, but it's also enormous fun for scientists and citizens. And so I'd leave you with this, and I'd say, just do it. Thank you.